Hello guys, welcome back. We're looking at another video for, in this case, the power rule, as you can see here. So we're going to go over the definition. So if n is a real number, then the function f of x is equal to x to the n power, differentiable. And here's a derivative. So we have the derivative, which is denoted by d, in terms of x's, of x to the power of n is equal to n, and then we have x raised to n minus 1. So I have another way of looking at it. Keep in mind a will be a constant. In this case denoted. As you can see, the derivative of this function with respect to x of a of x to the n is equal to n times a x to the n minus 1, where a it's in the real numbers. So for f, the differentiable at x equals 0, n must be a number such as x x to the n minus 1 is defined on an iterable continuous 0. So let's take a look at the first equation here. So if I decide to do the differentiation, so the derivative with respect to x of f of x, this is equal to the power, in this case the leading coefficient is a 1 here, and we have a power of 3. So therefore we multiplied 1 times 3, and therefore we get a simple 3 here, x. Now we're ready to subtract a 1 from a 3 here, so we get a second power. So that's the first equation, so that is our final answer. Now let's take a look at the second equation. So dx, and this is g of x. If we apply the same definition, so keep in mind here we have the cube root, and I'm going to note it on this upper corner, cube root of x, just like so. So we can convert that to a power by saying that this is equal to, the same definition will be an index. Whoops, let me get some more space here. So I'm going to try to erase that. So we can say the cube root of x can be defined as simply index here, and then our power, and therefore x, and this is raised to a power over index. So we can change that. So if we go back to our example here, dx, so we can say that this is the same as x to the, so this is our power 1, as you can see here's the number 1, and that will be to the 1/3 power, and this is equal to, once again you need to multiply 1 here times 1/3, so therefore we get 1/3 x, and then we keep the power there, so it's a 1/3, and we need to subtract a 1 from this number here. So when we do that, we need to convert that. So once again, another reminder here. So for a 1, we can say that 3 over 3 is equal to 1, 2 over 2 is equal to 1, and therefore, because I need a 3, I want to do 3 over 3, and therefore my final answer here is 1/3 x raised to the -2 over 3. Alright, so now we're ready to move on to the last problem, d with respect to x of y. We can say y, but it's in terms of x, just keep that in mind. So here we have 1 over x squared. We can bring the power up, but every time we do so, just like that, make sure you change the power to a negative. So if we apply the definition dx of x to the -2, so once again we need to multiply the actual leading coefficient here, which is a 1 times 2. I'm going to illustrate that here, 1 times 2, or rather -2. We get -2x, and now we need to take out a 1 from this 2 here. So therefore we get a -2 minus 1, -2 minus 1. So we get -2x to the -3. Now let's take a look at another example here. Here we have the derivative of t of x of f of x. And once again, our leading coefficient in this case just happens to be a 1. Our powers are 3, so multiply those two. We get 3x, and then we need to take away 1 from this power. Therefore, we get the second power. Move on, minus. We have our leading coefficient, which is a 4. Power is a 1. So we get 4x, and then we need to subtract 1 from it. So we get x to the 0. Oops, x to the 0. But x to the 0 is simply 1, and 1 times 4 is simply 4. So I'm going to erase that then. I don't need that, so I only get 4. And I have a plus 5 here. 5, it's a constant. Just keep that in mind. If it's a constant, I will say it's, let's assume that we have an x to the power of 0, and we get 5 times 0 is equal to 0. Therefore, if it's a 0 there, so we don't need that. We don't need to illustrate that. So all we get is 3x squared minus 4. Let's go over the next example here. We get d over dx of g of x. Once again, the leading coefficient, we have a negative here. Let me illustrate that, negative. But in reality, it's a negative, negative 1/2. And then we have x to the 4th power. So if that is the case, we multiply our leading coefficient times the power, and that will be basically a minus 4 over 2, and I'll simplify it afterwards, x, and then we need to subtract 1 here, so the 3rd power, and we continue. We have a plus sign there, so plus over here. We have a leading coefficient of 3 times 3 there, so that's equal to 9x. And now we need to take away 1 from this 3 here. We get a 2nd power. And let's move on. We have a minus sign now over here. Leading coefficient 2. Here's a 1 there. So remember, if you don't see it there, it's a 1, just like so. So we get a simple 2 times 1. And that's equal to 2. And then x. And then we need to take away a 1 here from that x. Therefore, we get a 1 minus 1, you get a 0. Once again, 1, any number to the 0 power is equal to 1. So therefore, I don't need to represent this. Let me erase that. So that is almost my final answer. Let me simplify this here. We have negative 4 over 2. Therefore, it's a negative 2x cubed plus 9x squared minus 2. Alright guys, I'm done with this. Thank you so much for watching. Do not forget to subscribe if you're liking the content. Thank you so much, and I'll see you around.